Hello, my name is Steve McQuarrie, and I'm a technical marketing engineer with Cisco's Data Center Product Group. This video is part of a series that is intended to show some of the unique advantages made possible by Cisco's server offering called the Unified Compute System, or UCS for short. This video will demonstrate how the UCS M-Series servers share components and provide a dense compute platform for scale-out applications. Thanks in large part to web applications, we're starting to see a new trend of app being developed. Instead of the traditional environment where we have a server running a hypervisor and many virtual machines under it, we're starting to see a single application that starts to take advantage of using multiple pieces of hardware. In this situation, we need to provide as many compute nodes as possible. Using a technology called System Link technology, Cisco has found a way to distribute or disaggregate the server from shared infrastructure components such as network, storage, and heating and cooling. This is known as the M-Series modular servers. It's a compact server containing 16 server nodes in 2RU based on our third generation VIC fabric. So we'll take a look at how this server works within a UCS environment. So here we have our chassis, and if we take a look at our individual chassis, we see that there are multiple cartridges in this chassis. And then within each of the cartridges, we have two server nodes. We also have storage. Now storage is the shared component of all of these servers. So instead of investing in individual drives for every server, here we have two disks that will be shared among the 16 server nodes. We also have a shared adapter. The adapter provides network connectivity up to the upstream network for all 16 nodes. Again, it's a shared component. So we're starting to separate the network and the storage from the individual server. Here we see that these network components connect up from a port channel to the peer switch, which are the fabric interconnects at the top of the connection. So from here we'll take a look at how this shared storage works. So the first thing we do is create a disk group policy. The disk group policy defines how we will put the RAID groups together, how we will mirror the drives, or what policy will provide on those drives. So here we're going to do a 2-drive RAID 0. Specify that we want 2 drives, and we'll take all of the rest of the default configuration here. So this is just a policy, and this is part of the power of this application or of the M-Series servers within UCS. We built a policy for what the RAID group is going to look like, and now we'll create a storage profile which defines what the actual drive looks like on an individual server. So we'll call this a Linux app server storage profile. And we'll create a drive for these servers. We'll call it drive in this case, and then it will get a number for each individual server. Make it small just to boot off of, so we'll say 10 gig. And then we're going to go back and select our disk group configuration. So this is the RAID group we're going to use for this drive. This will create a RAID volume within those two RAID groups. So we have our LUNs, we have our drive there, and we have our storage policy, we have our disk group policy, which is a 2-drive RAID 0. Now again, part of the power of this is simply a policy. So if we go back and look at the chassis, we'll see that the disks are still in an unconfigured good state, and we have no LUNs on this chassis. So in order to do this, we have to create a service profile. In order to establish that, I should say we have to create a service profile. So I'll create a service profile here called My App Server. Go through and select the typical UUID assignment, provide some networking information. So some of this has been previously set up. We have a VNIC template here for Ethernet 0. So I'll give it a name, select the template, and that provides a policy for me along with the application or the adapter policy, which is Linux in this case. And then we'll go in and provision storage. Now there's no direct attached storage here or no VHPAs, and by direct attached I mean each server doesn't have its own individual storage. So we'll go to a storage profile. We'll go use the global storage profile we created earlier. This is our Linux app server. And then we'll go through the rest of this configuration. No zoning, no VNICs, no vMedia policy. We do need to create a server boot order. We're going to create this server to PXE boot, so it'll do PXE install for EFI. So it'll check the local disk. If nothing there, go do a LAN boot for Ethernet 0. Configure through our maintenance policy. We'll do our server assignment later, but when we do our server assignment, we want it to be down in this case, just so we can watch what's happening. And then any other operational policies. Standard service profile that we get within UCS. So now we've created what an application server looks like, but we've still not instantiated anything. We have no LUNs. Our disks are still unconfigured good. So now we could replicate the service profile many times for hundreds of servers within our environment. We know what it's going to look like. It's going to instantiate the disk. So here we'll actually go and associate it to a server. So we'll select one of the servers. Now let's select something in the middle of our system here. So we'll go 5, 2, and we'll start associating that service profile. Now at this point, once it starts the association, it will actually create some of this shared storage we talked about. So now if we look at the LUNs, we see a virtual drive. We also see that it's assigned to a particular server. And then if we look at the disk, we'll see that they're online. We can go back to this LUN and go down to the bottom. We can get detail. You can see it's a drive. 1 is the name of it. It's RAID 1 mirrored, the total size and number of blocks, and the 2 drives that it's a member of. So these drives are shared among all of these compute nodes, and these virtual drives are assigned to an individual compute node so that they have their own individual storage, but it's shared among the components. This allows us to break up the life cycle. So if we need to change out compute nodes, we don't have to change our hard drives or our power supplies. If we have a failure in a hard drive, we don't have to take down a complete compute node. So we'll boot this server up, move through some of these screens a little quickly here. We'll actually accelerate how fast this happens. And this is essentially going to go through a PXE boot install where we're doing a slipstream of the drivers. So the system comes up, starts booting, starts installing Linux, and we get our packages. So while it's doing that, we'll go ahead and we'll create a clone of this server. Now typically what I would do is templatize this so I could do it multiple times, but in this case we'll just do a clone. So the service profile we've already created, we'll just create, I don't know, my second app server here. So this will become another app server with the same profile, different identity, and obviously it will need a different drive. So to show the power of this shared storage, we'll take the second app server here, and it's created, and we'll associate it to one of the physical servers in the environment. So let's pick something else from our chassis here. We'll go with server 7.1. So that's cartridge 7, server 1 within that cartridge. So as it starts creating and configuring, we can go back to our chassis. We see that obviously our drives are still configured. They were already a drive group, but we have this virtual drive 2. So virtual drive 2 is assigned to this service profile. In particular, it's assigned to server 7.1, cartridge 7, server 1, and it's on those same 2 drives. So this is some of the power of the shared storage. So I can create multiple devices and share the storage across that, as well as sharing the network through the Ethernet configuration, or I'm sorry, the VNet configuration that we created. So after our, we'll get our second one installing here as well. So now this server is going to go through the PXE install process. And while it's doing that, we can actually go back to our first server, which is completed installing and booted up. So we'll log into this server and take a look at some of the actual shared components and show that they actually work. So we'll take a look at our configuration. We created that Ethernet 0 interface. We'll go ahead and ping the gateway here, make sure that that is actually able to communicate. So we can ping off net. We see that works. And then we can take a look at the drive here, and we can see that as far as the operating system is concerned, both the network is available and there's actually a functioning disk. It doesn't know that it's a shared component. It sees it as an individual component. So we can do the same thing for our second server after it's completed booting here. We'll log in, check our configuration of our Ethernet interface, go ahead and ping our gateway, verify that that works. And then we can take a look at our disk here as well. So we see that they're an individual disk. Even though they're shared across the disk group within the chassis, each server has its own individual disk for this environment. We can look at the associated server, get some more detail here. We can actually take a look at the inventory and see the adapter. And one of the things that can show this is a shared component, we can see the serial number there. If we go to the other server here, take a look at its inventory and select the adapter there, we'll see that they share basically a serial number. So it's a shared adapter across the systems, as the drives are shared as well. To recap, applications are changing. We're starting to see a trend with cloud scale applications that run on many servers as opposed to one server running many enterprise applications in a virtualized environment. The UCS M-Series server was designed with cloud scale in mind. Its disaggregated components provides a flexible and consolidated platform for scale-out applications. This ends this UCS Advantage video, where we show how the unique capabilities in the Cisco UCS can lead to simplified deployment models with much faster service turnaround to meet the increasing demands of the business. Please go to www.cisco.com/go/UCS for printed collateral, including a brochure that highlights the information shown in this video. Thank you.